great song today. Don't touch your face. But today we're talking about finding zeros of a polynomial. All right, we're gonna have an assessment here next Thursday. Okay, so next Thursday we'll have an assessment over Unit 3. All right, again, next Thursday we have an assessment over Unit 3. I will give you a review guide. We'll pass out a review or post a review guide in the coming or later this week. And there will be videos explaining each problem of the review guide. Or I hope to make videos explaining each problem of the review guide. Let me just say that. All right. Okay. So today is a connection to our previous lesson. All right. Our previous lesson was on, given the zeros, find the polynomial. Now we're given the polynomial. We want to find zeros. Okay. We're not going to do the rational root theorem. We're not going to find the possible rational zeros today. We're just going to find the actual zeros. Okay. For the sake of time, we'll just find actual. All right. It says find the zeros of this polynomial. Okay. So the first thing I want to do when approaching problems like this is think about, can I factor this? Can I factor the polynomial that I'm given? Okay. And when we have 4 terms in a given polynomial, in order to factor it, in order to find the zero as a factor, I want to 2 by 2 group it. Now this only happens when we have 4 terms. Right? You can only do it when we have 4 terms. And I want to group it and see if it actually works. So remember when I'm doing 2 by 2 grouping, we've talked about this last week. We talked about this when we split the middle term as well. Hold on, I'm going to turn that off. All right, so remember when we do 2 by 2 grouping, I want to look for a greatest common factor. Okay. The greatest common factor between my first 2 terms here is x squared. Everything that's left over inside is x plus 3. The greatest common factor between my second 2 terms is 9, positive 9, and everything that's left over is x plus 3. And since we are solving this, I want to set that equal to 0. F of x now becomes equal to 0. All right, these x plus 3 match, so we're good. That means we did this correctly. If these parentheses do not match, it means you have to go back and readjust whatever your greatest common factor was. My second factor is x squared plus 9, and again, this is equal to 0. All right. Now that this is completely factored, I can't factor to x squared plus 9. If it was x squared minus 9, I could. Okay, so now that this is completely factored, I'm going to set each factor equal to 0 and solve. Wow. So when I set x squared plus 9 equal to 0, subtract the 9, take the square root. Now the square root of 9 is plus or minus 3. Okay, but this isn't 9, this is negative 9. Since this is negative 9, I need to take out an I. Okay, remember that the square root of negative 1 equals I. All right, so anytime you're taking the square root of a negative perfect square, you have to have that I there. All right, so our zeros are negative 3 and plus or minus 3i. So in our previous lesson, we went from our zeros or our roots and tried to find our polynomial. Now today we're given our polynomial and finding our zeros. All right, so that's a big difference from today and yesterday's lesson. Okay, now I'm going to show you something. This is long division, everyone's favorite. Excuse me, I want to review it, okay, because it's important that you see it at some point in this course. Yes, all right, so it says find all the zeros of the polynomial. I'm going to pause this for a second. If you have a graphing calculator, it'd be helpful if you take that out right now. So, all right, so to find the zeros of this polynomial, what I want to do is I want to enter it in my graphing calculator. Okay, so I'm going to go do that now. X to the 4th. Try. Hold on. So y equals. Go to your y equals. Now you can see my keystrokes down here. All right. X to the 4th minus 3 x cubed. What the heck? All right, sorry. So the thing couldn't handle me flipping back and forth. So I input that into my y equals, right? Into my y1 here. Okay. And then I go to second graph to look at my table. and I look for some zeros. Okay, now obviously I see 3 right away. All right, well, I'm going to use the first one. I'm going to use 1. And what I'm going to do with that is I'm going to perform long division. So if x equals 1 is a 0, then remember x minus 1 was the factor. All right, so in long division, here we go. This is fun. Everyone remembers long division, right? I'm going to write x minus 1 out here. And I'm going to make my big there, and then I'm going to go x to the 4th minus 3x squared minus 2x squared plus 12x minus 8. All right. So now, remember, what I want to do is figure out, okay, what I'm going to have to multiply to x to get to x to the 4th. This should be x to the 3rd. Okay. Well, I'm going to have to multiply x cubed. So I think about it as this, x to the 4th divided by x, I get x cubed. If I multiply x cubed to x, I get x to the 4th minus x cubed, because I have to multiply x cubed to negative 1. All right, and what I like to think about this as being, this is in parentheses and I'm subtracting. So plus negative plus. If I subtract this whole thing, that means everything in here, the signs change. Okay, add straight down. These cancel out. Negative 3x to the 3rd plus x to the 3rd gives me negative 2x to the 3rd. All right. I should bring down negative 2x squared as well. And maybe this 12x, just for funsies. Okay. Now I do negative 2x to the 3rd, so the first term here divided by my first term up there. And I get negative 2x squared. So this negative 2x squared goes up top. Some of us may be able to do this part over here on the right in our head. That's okay. I'm just showing you where it comes from. All right. So now I do negative 2x squared times x to get negative 2x to the 3rd. Negative 2x squared times negative 1 to get positive 2x squared. Parentheses, I want to subtract, which makes, I'm going to change to a positive, which makes this one positive, which makes this one negative. Remember, when you subtract, you change the signs on what's on the inside. Why do we do that? All right, well, as you can see, that cancels out, and this gives me negative 2 and negative 2 gives me negative 4x squared. Wow. Plus 12x, bring the 12x down again. Okay, again, we're adding straight down. Negative 2 plus negative 2 gives me negative 4, and 12x just comes down. Okay, 12x divided by, or excuse me, not 12x. How rude of me. Negative, all right, sorry, got lost there for a minute. Okay, so negative 4x squared divided by x, I get negative 4x. That's what goes on top. So I multiply negative 4x times x to get negative 4x squared. Negative 4x times negative 1 gives me plus 4x. Wow. Draw my line. Again, we are subtracting this whole thing, which makes this positive and this negative. Okay, if I add straight down, these cancel. Whoa. 12 minus 4, I get 8x. And then a negative 8 from the beginning. Finally comes all the way down and plays its part. Here we go. So now I know that this is going to be 8x divided by x. I mean, you can do this in your head, I'm sure, but I'm going to write it out just for funsies. 8x divided by x, I get 8. So I have plus 8. All right, multiply the 8 to everything. So I get 8x minus 8. Uh-oh. This is a good thing. All right, this is what you want. you want to have a 0 down here. So now that you know that it's factored. Okay, so I know that x equals 1 is a 0. All right, so now I'm going to take this right here. Okay, this x cubed minus 2x squared minus 4x plus 8, and I'm going to keep factoring that. So I'm going to take x cubed minus 4x squared, what was it, minus 4x plus 8. And I'm going to continue to factor this because when you're factoring a degree 4 polynomial, I should have 4 roots. All right, I'm going to pause this here and I want you to 2 by 2 group this. Go. All right, so from here, okay, what did I do here? So I 2 by 2 grouped and I broke it down here, took out an x squared, took out a negative 4. I want to take out a negative 4 since this first term here is negative and I want it to be a positive x. I got x to be 4 here, x squared minus 4 equals 0, x is plus or minus 2. So my answer is x equals 1, 2, negative 2, and 4. Now remember the 1 came from up here. All right. So now I'm going to show you how to do the same problem in a completely different method. Again, I'm going to use x equals 1. Okay, so now we're going to use synthetic division, which people tend to like more. It's a little bit easier. Okay, I'm going to put the 1 in the box since that's what x equals. All right. If it was a factor like x minus 1 was the factor, then I would put the opposite in the box. Okay, so you want to think about what is the actual root. The actual root is 1. I'm going to take the coefficients of the top, so 1, negative 3, negative 2, 12, negative 8. Again, that comes from the coefficients up here of my polynomial. I draw a line across, okay? When doing this, all right, the first term comes straight down, I get 1, okay? I do 1 times 1, which gives me 1. And then I add these two, negative 2 plus 1 to get negative 2. Negative 2 times 1 gives me negative 2. Add straight down again, I get negative 4. Negative 4 times 1 gives me negative 4. Add straight down, I get positive 8. 8 times 1 is 8 to get 0. Okay? So from here, since this is x to the 4th, that means this is x cubed minus 2x squared minus 4x plus 8. Okay? So notice how this is always going to be 1 less than the degree of my original polynomial. All right? Whatever comes out here, our result, if this is a 0, that's a good thing. That means 1 was an actual root. And then I could 2 by 2 group that by factoring. All right, but I already did that here. Okay, so I'm not going to redo that work. All right. Let's talk about rational versus irrational roots or numbers. Something that's rational ratio is in the word rational. So like 1/2 is a ratio, that would work. 3/2 is a ratio, it's a rational number. 4, 3, anything that can be expressed as a fraction is a rational number. Irrational number is like pi, root 2, negative root 5. Those are all irrationals because they can't be expressed as ratios. Okay. Steps of finding the zeros of a polynomial. I talked about these. I just want to make sure you have them written down. Use a calculator to find one nice intercept. Okay. And we want to write, so let's say x equals 2 was an intercept. Then I want to write that as x minus 2. If I'm doing long division, or if I'm doing synthetic division, I'm going to leave it as x equals 2. Okay? And I mean plug, for step 1, plug into y equals, and look at the table. Divide, complete divide until you can factor. Use any method you want to solve a quadratic. You want to do this until you can factor. If you can 2 by 2 group, that's fine. If you get a quadratic, that's even better. Again, you're going to have the choice now to use synthetic division or long division. I'm sure you're going to choose synthetic, and that's totally fine with me. Okay?